Starting from where we previously left off, we have the to square function, the to cube function, and the to homework function. We defined these functions for understanding how the functions work, for the parameters, and how we can perform complex mathematical arithmetic operations with functions easily without having to repeat the same code again and again. For this video, I will be focusing majorly on error handling. What error handling is that you let's say give someone this function to square. However, instead of number, the function that you give it contain the name parameter for its parameter. So if I do help to square here, it says help on the function to square in module main to square parameter. Now obviously from the name of the function to square, I know that it should be passed a number. However, this is not the case when you are dealing with large codes, really dealing with complex codes, or dealing even with multiple parameters. For example, we need to make sure that our code is to a specific degree safe from wrong inputs. For example, if I do a 2 square of, let's say, 15, it will give me an answer, and if I do a 2 square of 15.9, it will give me an answer. However, if I do 2 square of, let's say, a, now it will give me an error. It says type error, unsupported operand type for double star or power operator, string or ending. It is saying that I cannot perform the double star operator on a string type. If you want to know what type of parameter you are passing in, you can just type and then the parameter. So it says the type of the A is string. There are several levels to error handling that you can use within a function. Some are very general, some use some specific constraints. Then there are those type of error handling that you can perform with the wrong input when you still want to process the function even if you are given the wrong input. So we will look through them one by one. So first we will deal with the assert keyword. So we will type assert. What it does is that it implements a specific logic or condition that I will pass in next to it, and if that condition is satisfied, it then gives an error. However, if the condition is not satisfied, it can give the user an error message or a warning that we can write after that. So what we do not want here in the to square function is that we do not want the parameter to be of string type. So type assert type parameter is not string. We do not want our parameter to be of string type. If the parameter passed is of string type, we can say that the string type is not implemented by to square. The string type is not implemented by. Okay, I don't know why this is not going away. Parameter, my bad, spelling mistake. So again we do the to square 15, it's fine. 15.8, it's fine. Now let's do the A again. So I passed in a string to the function and it said assertion error, the string type is not implemented by to square. However, if you remember previously, it gave me an error type that the function was unable to perform on the string type. So we have changed our error by using the assert. This is a very basic type of error handling. It is usually, or at least I usually use it when I'm writing up the code when I don't usually bother with so much error handling. The second type of error handling that I have used is using the isinstance keyword with an if statement. So the basic idea behind that is that if the instance of the parameter passed is of a certain type, then we can raise an error. So it is manually raising an error just like an assert error. However, we do not raise the assertion error, we raise whatever type of error we want. So let's implement that on toCube. We will say if isinstance number string. If the instance of the parameter number is of type string, raise let's say we raise here assertion error as well, just for because we do not want to raise the whatever natural error, for example type error, that will happen. So we are raising assertion error. Let's say I raised this error manually. Okay, so let's do that, and let's do the toCube. Let's go with A again. So again, now since the is instance, let's just check it for our that is instance a string. It is true because A is a string type. We can check that with type A. So string is instance A string is true. This if condition is evaluated. Since this if condition is evaluated, it goes to this command, it raises an assertion error, and because the error is raised, the code doesn't do anything and it breaks out. Now the toCube function will work properly if I pass in 15. However, a more safe sort of way is to return the values after the else statement. If this assertion is not raised, fine, return the number cubed. Next, I want to talk about the try except block. The try except block, as you can guess by the name, it tries a certain code. However, if it fails, then it goes to the except block, and then it execute the code in the except block. There are two more levels to the try except block with an else and finally condition. However, we will not go into them. We will try to remain within the try except block. So for that to be implemented, what I want to do with the toHomework function is that I want to perform the calculations based on a number. Obviously, I do not want to have a string in my function. However, if a user passes a string, instead of raising an error, I want to return a -1. So let's try to implement that. Try this whole code block except as we saw with the toSquare initially, when we try to do or when we try to perform arithmetic operations on strings, it gives us a type error. So let's say accept a type error, and if the type error occurs, the code will shift from try block to the accept block, and what I want to do is I want to return a -1. So let's see if it works. Do homework. 28 works fine, 28.8 works fine, and A, it gives me a -1. It is not necessary to pass a -1 value. You can perform some other calculations for maybe not in this scenario of toHomework, but in any other case, maybe in some complex code you want to perform some other calculations if a number is greater than a certain thing, or if the list is passed, if an I don't know, single string is passed, something like that. So this is a convenient block to perform multiple to execute multiple blocks of codes depending upon some predefined conditions. As in this case, the condition is that the input should not have been a string. Now there is another type of condition error handling control is pretty frequently used, is that make our own error classes and then we raise those error classes. Let's write another function. Define I can't accept 5. So this is a function. It takes input of a number, okay, and it just returns the number itself. However, there is a condition that the function cannot accept the number 5. There is nothing stopping you from passing in a number 5. Do it one by one. So we can do assert number is not equal 5. We can do the passed number is 5 not acceptable. So I can't accept 5. Assertion that the passed number is 5. Fine. The method that is more appropriate for this type of errors is to raise the errors manually. For that we can define let's move it up. Okay. To raise error manually, we can define an error class, my error class, with the parameter exception. I can define my own errors, like don't pass 5. I can pass in my error class here, oops, and do the pass. Now what I can do is, if number double equal 5, raise don't pass 5, and I can directly write the error message here that don't pass 5, and it should work. Let's add the else condition, else return number. Let's try it. So I can't accept 5. Let's say we try 6, it gives us 6. If we do 5, it says don't pass 5. It has raised the error class that we have given it here. The advantage, I think, of this specific type of error handling with classes is that you can directly say to the user that please don't pass 5, or don't do a certain task, or if the error is raised due to a certain other condition that is met that is not user oriented, then you can also tell the user that the error has been raised due to certain condition. So this is it for this video. Thank you for watching.